Alright, this will be a fairly quick section to lecture on, but when you sit down to do the homework, it'll probably take you just as much time as the earlier sections of Chapter 5. This is where we bring together 5.1, 5.2, 5.3, 5.4, and 5.5, and we talk about an overall factoring strategy from all those different sections of techniques that you've learned. So, it's fairly quick to say what that overall strategy is. But then when you're sitting down to do the homework, what you should expect is a whole bunch of factoring problems with no organizing principle. Each problem you'll have to look at and determine which technique from Chapter 5 do I use. And that's going to be a little bit more challenging than if you just know they're all going to be of one type. So it takes a lot of practice, but we can go over the basic ideas fairly quickly. First of all, there is something that everybody should be doing all the time. It's not a factoring strategy, but when you're factoring, you should be doing it before you get started at all. And in fact, I'm going to call this step 0. And what this means is rearrange the polynomial by collecting like terms and putting things in descending order. In other words, put the polynomial in proper form. So that might be rearranging in descending order, that might be collecting like terms, it might be eliminating some redundant parentheses, but whatever it takes to put the polynomial in proper form, make sure you do that first. It'll make the rest of your work a lot easier. Then, step 1, look for a common factor. And I warn you, people overlook this a lot. They jump into something more fancy, and it could have been a much simpler problem if they'd simply factored out a common factor. So always look for a common factor first. Your life will be much easier. You'll have much easier time factoring if you do that first. After the common factor is pulled out, what's left, count how many terms it has. And depending on whether it has 2, 3, or more terms, you'll use different techniques. If it has 2 terms, you're going to be using either the difference of squares, and remember that's from section 5.4. I'll also pause for a second and remind you that the sum of squares does not factor. So if you see a plus sign between 2 squares, what you do is you say it's prime. Or if you've got 2 terms, it could be a sum or difference of cubes. And that's covered in section 5.5. Here in Math 89, we're not going to cover that until week 1. So don't expect to see any homework problems on that. Or if you do, don't worry, we're covering it in week 1 well before the due date. So section 5.5 will get covered. You will learn about cubes. But if you don't already know about cubes, that's probably why. If you have 3 terms, if you have a trinomial, the technique you're going to use is the techniques from section 5.2 and 5.3. Guess and check, using FOIL, figuring out the possibilities and eliminate possibilities. And the only way to get good at that is to practice. Everybody wishes there was a shortcut. Everybody wishes there was a formula. And there are some shortcuts and there are some formulas, but they don't work to make you any faster. And if you ever want to be able to do these quickly, which is sort of the point, you need to practice. So this topic here, guess and check using FOIL, you have to practice and practice and practice and practice and practice and practice. If you have more than 3 terms, then unfortunately there are no techniques. The only thing that might possibly work is way back in section 5.1, we learned that factoring by grouping thing. You might be able to use that. That's your only hope. It's not guaranteed to work, but it's the only thing that we've got. As you work through any particular problem, and we've seen some examples earlier in chapter 5, every factoring step you do, The pieces that you break your polynomial down into, you need to look at each one of those and consider whether it might factor more. Because if you don't factor completely, you will never get full credit on a problem. Anytime you're told to do a factoring problem, the assumption is that you're going to factor completely. If there's more factoring to be done, then you aren't finished. And then my last piece of advice is a bigger piece of advice than it might appear at first. Whenever you factor something, when you're done, you should check your answer by multiplying it back out. That's not just so that you're confirming that you're right. And honestly, we all get kind of lazy about that sort of checking. Did I check my answer? Maybe. But you really should when you're learning factoring, because the checking process isn't just telling you you're right or wrong, it's also teaching you how to factor, which is kind of a strange thing. You haven't really seen that when you were learning to, say, solve equations or graph lines. Here, checking is teaching. And as a professor, we all know which students are actually checking their answers and which ones aren't. The ones who are checking their answers, they get very good at factoring very quickly, usually within a week, less than a week, just a few days sometimes. And the students who are really struggling with factoring, when you look at their work, they aren't checking. So this piece of advice here is different from when I usually tell people to check. Usually it's just nagging to remind you should find out if your answer is right or wrong. Here, it means you will learn better. So in section 5.6, make sure when you're doing any factoring using any type of factoring, you always check your answer when you're done.